Hi everyone, welcome to our first lecture for our second week. In this first lecture, we're just going to be covering a bit of concepts about objects in Python and referencing constructors and some terminology before we delve into actually coding our classes. So if you've read through chapter 8 and you feel pretty comfortable with the terminology behind objects, feel free to skip this one. We're not going to be making our own class in this video. In the next one, we'll be doing it. With that being said, there's going to be around three properties that we're going to be focusing on in this course. And the good thing about learning it in Python is that this is applicable for all the other types of languages that you use as well. So we can actually try to code some of this here. The tree properties are an identity, a type, and a value. So essentially, we've seen types and values quite a bit already. Types that we've seen such as integer, string, boolean, floating. And value here is usually what the value that is inside. If you can consider a variable a box, the value is what's inside of the variable. Now, this identity is a bit more unique, and sometimes it could be tougher to understand where it is. But the identity of an object is this unique integer ID assigned to that object. And essentially, that is what the memory address or where it's stored in the memory of the object is. Now, how do we actually create this? Well, why don't we try to do that a is equal to 7 in our code? And if I do ID of A, you'll notice that I actually get a much different memory address than the one that's given in the example here. If I reassign it to a string, like so, we'll see here that a bit of the same memory address at the start, but at the end it changes a bit as well. Now, if I make a different object of 5, we'll see here that I'm getting the same 207. And you'll notice on this side of the code that we're actually getting the start of the 505. So if you're if you're asked like what is the identity of something, that's where we are saying the memory address is. Now we've done this a bit last week during our lectures where we look at the type, but if you could see here, we have two different types going on, which is essentially what the type of the object is. So again, we've seen different types such as Boolean, string, and int. And again, the reason that it's important to know the type is that we need to know what we can do with it, right? If I do a plus b now, we'll notice that I have two different types. I'm getting a type error because a is a type of int, a is a type of string and b is a type of int. Straightforwardly, this value, that's essentially what we have when we type it out. So like, what is the value stored at this memory address? That's what this is referencing here. Cool. Now, if you've looked through some of the chapter notes already, you might have heard this term constructor. And constructor essentially is what we're going to use when we create our own classes. And before we actually look at the code of making the constructor, we're going to take a look at some examples of what's actually going on here. So with int and list, if we actually type out the word int like so, we'll notice that this kind of returns this idea of class of int. But if I type out int with an open parenthesis, you'll notice we get this kind of weird layout of two pieces of text where it says int over to integer, int x base equal to 10 over to integer. Now if I close this, what this actually does, you'll notice it gave me a 0. This looks a little weird, but essentially this is what happens behind the scenes in Python when you create a new object that's an int. So if I do a is equal to 5, what you're actually typing, if you look at the bare bones code, is a is equal to an object called int with the value of 5. So essentially, we have been using a is equal to 5 here, but as we get into more object-oriented programming, this is what we're actually going to be doing more. So I'm going to create an object that is of type int, that is an int object, and I'm going to give it the value of 5. Now, what happens if I do b is equal to int without that value there? We'll notice that my b defaults to the value of 0. You'll learn how to do this default later on, but for the time being, it's very helpful to see what's going on behind the scenes. Now, is this only for, should I restart my shell here? Let me just save this for later too. Sorry about that. Cool. So now what's happening here, we can ignore that test for the time being. I just want to get this to run for us. Is that this happens with all of them. So if I say a is equal to hello, like so, what's actually happening is I'm saying a is equal to a string. And let's see if this will work for us. Yep, so A is equal to the string of hello. What happens if I do a default of B is equal to string? Then it's going to be empty. So right now, these are the built-in objects of Python, string and int, and this is what we're doing when we create our own custom classes. This is how we're going to be creating the objects a part of them. Cool. Now, again, you could see here that if we give parameters to use or we don't, it's going to change the value of it. And now with our terminology here, we're going to take a look at a bit more of this concept of attributes. So essentially, every class is a list of class attributes, which are variables and functions. So attributes are this concept where we can apply it to our humans as well. So each human has an eye color and a hair color and maybe a height and a weight. And what we could do is also associate functions with them. So or methods, as you could see here. Functions or methods are interchangeable. So if you're referencing them as methods or functions, it's the same idea. But essentially, a function is something that we've been creating so far. And a function for humans might be like walking or eating or talking. So that's where these attributes come in. But this attribute kind of combines those two ideas into one. Now, each object of a type inherits the class attributes, such as the variables and functions. And now, what is with this inheritance idea? We are going to look at it more, and it's more easy to see than what's happening down here later on. But let's just go ahead and try to type out help of int, like so, for the time being. And this help function is not, so if we were creating our own objects, we won't really be able to get the help function in there because we have to write it. But if you're working with built-in Python ideas, it's nice to use the help function to see what's going on. But we could see here that we have this concept of subclasses and we have these attributes defined here. So we have these attributes of ABS, absolute value, add, and Boolean, ceiling, and equal and float. There's a bunch of stuff going on here, and this looks a bit like a lot at once, but one thing that I want everyone to notice right now is that we have these two underscores, and this is going to be really important later on when we try to override these operators. So these are all functions or methods, as it says here, that are defined a part of the class, and you can see here that we can also go ahead and look at the help of list. Sorry, the help command is massive. And you'll see here that it goes ahead and does something kind of similar to us. And list also has, if you look here, it also has an add command. So you'll see here that there's an add for list and there's an add for integer as well, but they operate quite a bit differently. There's the add for integer, return self-value. It's doing the same thing, and this is where I wanted to look at this concept of inheritance. So if we have a human object inside of our code, we might be more specific to make a specific character, like a student object based on a human. So student has all the same attributes as a human does, but they might be more specific, such as having a class or like going to a certain university. Don't worry too much about all these the code and the helping so far, as long as you're getting the general idea of what's going on here, such as attribute and attributing to like what's going on in your scenario, that'll be fine. Cool. So now we're going to take a look at operators as well. And this is where we can get a little confused if we are new to object-oriented programming. Just make that an empty one. And I'm going to run this. So what we've been doing so far in our code, similar to how we were creating objects basically, and then we use the constructor to make them. We usually do something where we do like x plus y, and that gives us an 8. What's actually going on behind the scenes here is that x is an integer object which has an add overridden command. We saw it earlier right here. This is what is part of the int. And the actual code that goes on is that if you do x plus y, you're calling the add method that is a part of the integer x, and you're providing it a parameter of y. And that's what this is actually referencing here. So that's what the code in the background is. And we'll see here that when I do this, it actually adds them together and gives me the same result. What about subtracting? It's the exact same idea, right? 3 minus 5 is -2, so x minus y, and this works for every single int object that you make, which is a very important thing to remember because these objects might have different scenarios here. So again, if I do y is equal to, let's say, a list of 5 here, and I do x add y, we'll see here that we actually get an error in the backend that says not implemented. So that's something that Python didn't implement. And we're not getting the regular error where we get a type error because we're using this more abstracted idea of adding them. Again, what's going on here is that these are methods a part of it. And one thing I want everyone to remember is that these double underscores represent something that's built into Python and that we're going to use them quite a bit when we're creating our own classes. Great. And again, this works for all of them. There's a string method as well, which we'll look at too in a moment, which is a string representation of Python as well. And again, please review some of these slides up here for the first 3 pages just to understand terminology. Main points is to just make sure you get the distinction between identity, type, and value and understand how attributes work. Sometimes the analogies can get a bit convoluted because it doesn't account for every scenario. So try to come up with some analogies yourself as well. Human and student is a good one. Dog and animal will be using quite a bit as well. But before try to come up with a few of those before you actually start into jumping with the code. So in our next lecture, we'll jump into coding all of these concepts and trying to implement these with our own custom objects.